So in this video, we continue solving problems from exercise 8.1 from chapter number 8, quadrilaterals. So here we are going to solve problem number 10. Let's read what the problem is. ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on the diagonal BD. Okay, so let's try to trace out the things that are mentioned here. So A, B, C, D. Okay, it's a parallelogram, and BD. Okay, you can see that BD is a diagonal. Now, from this vertex A, they have constructed a perpendicular on this BD, and this perpendicular line meets BD at a point P. So this is that point P. Similarly, from this vertex C, from this vertex C, they have constructed a perpendicular which meets the diagonal BD at a point Q. So once again, let's highlight this point Q. Okay, so this is a thing that has been done. Now show that triangle APB. So APB, this triangle. Okay, in fact, I'm going to use a highlighter to mark it. So APB, this triangle is equal to CQD. Okay, so CQD is the other triangle. So this is CQ and D, this triangle. Okay, so we have to show that the triangle highlighted in the pink is equal to the triangle highlighted in the green. We have to show this congruency. The second thing that we will show is AP is equal to CQ. Now this will follow from point number 1. If we prove that this triangle is equal to this triangle, then as you can see that AP, this is equal to CQ. Okay, those will be the congruent sides from the one-to-one correspondence. So that will be an easy part to show. Okay, so let's first clear this. Okay, clear this also. Okay, so let's focus on the first part. Now we are going to use the same diagram, and I've just noted down the question here once again. We have to prove that APB is congruent to CQD. Now in APB and in CQD, we can see that one angle is 90 degree, which are congruent to each other. Okay, so first let's quickly make a note of that. So point number 1, angle APB is equal to angle CQD, which is equal to 90 degree. Okay, why? Because this is given. Okay, this is given. This is how the construction has been done. Those two lines AP and CQ are perpendiculars to the diagonal, so the angle is going to be equal, which is 90 degree. Now there is another angle which is congruent to each other, that is this angle. Okay, angle, you can say angle CDQ. Okay, it's congruent to this angle, this, that will be ABP. Okay, why they are congruent to each other? Because this line is parallel to this line and this is the intercept. So this is the alternate interior angle which gets formed because of the intercept. So let's mention that as our second point. Now the way the order of the angle is going to be very important, so you have to be very careful about that. So in triangle APB, it's going to be ABP. Okay, so ABP. In fact, let me write 1 2 3 here. So it's going to be 1 2 3 ABP, and we have to follow the same order in the other triangle. So it's going to be 1 2 3 CDQ, CDQ. Okay, so let's write that. Yes, so what I'm going to write is diagonal BD. Okay. Diagonal BD is an intercept, for two parallel lines, and which are those two parallel lines? CD and BA. Okay, so CD and BA. Therefore, angle, so let's follow this 1 2 3, angle ABP is equal to angle CDQ. Okay, why? because alternate interior angles. Alternate interior angles. Yes. So we have proven, in order to prove these two triangles are congruent, we have proven that two angles are equal to each other. Now the third thing that we might need is the side. Once we prove that one side is congruent to the other side, then by AAS test of congruency of triangles, both the triangles will be congruent to each other. So once again, carefully, if we look into this diagram, we know that the opposite sides of the triangle are, the opposite sides of a parallelogram are equal to each other. So AB is equal to CD. So once again, I'm going to use a highlighter here. Side AB is equal to side CD. Why? Because they're opposite sides of the parallelogram, and opposite sides of parallelogram are equal to each other. So that's going to be my point number 3. So let's go ahead. Yes. So point number 3 is going to be side AB is equal to side CD. Why? Because they are opposite sides of parallelogram. I'm just going to write P dot for parallelogram. And now thus, point number 4. Thus, by angle side test of congruency. Okay, angle side test of congruency. We have triangle APB as congruent to triangle CQD. Okay, which is exactly what the first point asked. So let's try to zoom in. Yes. So the first point is done. Triangle APB is congruent to triangle CQD. Now, the second point is very obvious. AB and CQ are the two sides of the triangle which we have proven are congruent. So once we prove two triangles are congruent, the three sides and three angles of the triangles are also congruent to each other, and therefore the second point is also proven. So this is the solution for problem number 10.